So Bakelite is a thermostatic polymer. Thermostatic means it cannot be softened on heating. It is a phenol formaldehyde resin. So phenol and formaldehyde are the starting materials in preparation of the Bakelite. These two are treated in presence of acid or any basic catalyst and initial reaction which yields the hydroxymethyl phenols. See, this is ortho position of the phenol and this is the hydroxyl methyl group. So it is a ortho hydroxymethyl phenol, and this is a para position. It is a para hydroxymethyl phenol, and sometimes we obtain trihydroxymethyl phenol. Here this is the second position of the benzene ring. This is the fourth position, and sixth position 2,4,6 trihydroxymethyl phenols are formed. Further, these hydroxymethyl phenols are subjected to condensation reaction. Here this is hydroxymethyl group and this is the hydrogen from the phenol. Here phenol and hydroxymethyl phenols are added in different ratio based on the requirement, like 70 to 30% or 25% to 75%. In this way different ratios are maintained based on the requirement. Here this hydroxymethyl phenol provides the OH group and phenol provides the hydrogen, and which are eliminated in the form of water molecule. In this way a condensation reaction, the condensation polymerization reaction occurs between the phenols, hydroxymethyl phenols by eliminating the small water molecules. And here we obtain a straight chain fusible polymer. It is a aromatic straight chain polymer which is known as Novolac. Now, since this Bakelite is a thermostatic polymer, before it is converted into strip form, desired article or shape, the Novolac is fed into the mold. In that mold, we add hexamethylene tetraamine reagent. This reagent provides formaldehydes. Which provides methylene group for the bridging between the two adjacent Novolac chains. So this CH2 will form cross-linking between the two adjacent Novolac rings, so that the structure is become rigid and forms a cross-linked structure, Bakelite. Now it is become thermoset polymer, and the properties, it is said to read hard, scratch resistant, infusible, water resistant substance, and it is also resistant to non-oxidizing acids, salts and many organic solvents, but it is attacked by alkalis because of the presence of hydroxy group on the phenol. This hydroxy group is acidic in nature. It can provide H plus ion. So since H plus is here, hydrogen is acidic in nature, it can be attacked by alkalis very easily, and it possesses excellent electrical insulating character. This is the main property of the Bakelite. That is the reason it is used for making the switchboards, heater handles, plugs and switches, and not only that, iron box handles, and this is the kettle base or handles. All these are made of the Bakelite, since it is a very good electrical insulator. And components of the television, these are old TV or telephone or radio components are made of all these are the molded articles made by the Bakelite. Next, this Bakelite is also impregnated with fabrics, wood and paper, means can be used in composite materials also. So by mixing it, we can convert it to composite also. Here this type of paper or wood can be made by mixing with, by impregnating with any other fabric, wood and papers. Next, used as grinding wheel adhesive. So these are the adhesives used for the wheel base. Next, used in paints, varnishes, and also acts as a hydrogen exchanger resin. These hydrogen exchanger resins used in the ion exchange method in water softening is used for making non-lubricated bearings. Non-lubricated bearings can be used. This is a non-lubricating bearing can be used in propeller shaft for paper industry and rolling mills. This is about the Bakelite.